Okay, we can move on to our next talk. This is from our SRE team, from Aakash and Deekshit. We couldn't achieve our success without the support and collaboration from them as well. And then we'll go through basically the infrastructure excellence and how we support this in a multi-cloud environment as well.
Thanks, Ken. Hey everyone, myself Aakash, and today we are going to talk about FoundationDB infrastructure excellence. Basically, this talk is around how we are managing FoundationDB infrastructure at Adobe. So before we start, I'm going to talk about, I'm going to present this, and with me, Deekshit is going to present this. We both are site reliability engineers, and we have more than 10 years of experience. And our area of expertise is we are managing infrastructure at scale and across multiple clouds. And we have experience in managing multiple distributed databases like Aerospike, FoundationDB. And our key responsibilities at Adobe is majorly we are taking care of the FoundationDB infrastructure and all the related tasks for operations, observability, and automations. So the agenda for today is we'll start with a brief intro of how FoundationDB looks at Adobe, and then we'll focus on the cluster provisioning part and also show you how we are doing cluster configurations. And then Deekshit will talk about the operational and monitoring and performance health, all the operational aspects for the FoundationDB. So starting with the setup at Adobe. So we have a multi-cloud setup. Yeah, we are in multiple clouds for FoundationDB cluster. We have clusters in different clouds. And yeah, we are using virtual machines. All our FoundationDB production clusters are right now using virtual machines. In some of the dev environments, we are exploring FoundationDB operator. But for now, all the production clusters are using virtual machines and are running fine. Each of our virtual machine cluster has the capacity to store around 4 TB of raw data. So we have a very easy self-service provisioning pipeline setup for FoundationDB, which can create cluster in any of the cloud environment we want. We have a very streamlined auto-healing process. In case some node goes down, the nodes easily come back, they get the configurations, and then they join the cluster back. Our clusters are very much fault tolerant, and I'll give you a brief on how tolerant they are. So majorly, all the clusters in production are running in multi-AC setup. So this multi-DC setup is, here we have 3 availability zones, and we have divided these into 3 DCs, which is primary, satellite, and secondary. So this is how the FoundationDB setup looks like. And in case of a complete availability zone down in any of the cloud provider, our FoundationDB cluster will be still working. So let's say a primary region complete availability zone goes down, our secondary will become primary in some seconds and will be able to take all the load. And what if satellite goes down? As satellite does not have any data, so primary and secondary will keep on running and they'll serve all the reads and writes. So now I'll be covering the provisioning part. So for FoundationDB provisioning, because we tend to expand our application to multiple regions, so we frequently need to provision FoundationDB clusters in different regions. So that's why we created this workflow, which creates FoundationDB in multiple clouds. Which is a self-service because you only need to provide some parameters like environment, name, region, IP block, what kind of cluster you want. If you want a small cluster, which is around 15 node, if you want a large cluster, which is around 45 node production cluster. So these are details you can fill and then workflow can be triggered. So which basically does the templating and commits the code to the RISC repo, which eventually generates a PR and we can see what are the resources our infra provisioner is going to create. And once the plan succeeded, it applies everything and we can see all the cloud resources for the FoundationDB. So once the cloud resources are up, we have proper config management in place, which configures our virtual machines to create a FoundationDB cluster up and running. And this config management also helps us to auto heal our if in case a node goes down, or if there is any issue in the cluster. So this is the provisioning process. Now I'll be putting some more light on the config management. So this cluster configuration has 5 pillars. So these 5 functions are basically responsible for configuring different PCs in FoundationDB. So there is a base OS function which install all the base packages, set up all the security requirements. It sets up the monitoring, it configures LDAP. And then once everything is done, we have a FoundationDB install function, which creates FoundationDB directories in all our FoundationDB machines, and then install FoundationDB package that we require to have. Then we have a function for FoundationDB certificates. In FoundationDB, we need multiple certificates, and we are using self and CSRT so that we are creating per FoundationDB cluster, and then we are signing the peer and client certs, and then ultimately committing all the certs to what. So then comes the major part, FoundationDB configure. So this function take care from the, it configures the machine from scratch because we are using NVMe disk. It formats them, mounts them. It configures the class. FoundationDB has different subsystems like storage, card log. So based on the machine tag, it pushes all the configurations that are required. Like if it is a storage machine, it has a storage tag, it will push the storage configuration to that machine and build it. And it also configures logging. And once everything is done till configurations, we move to the FoundationDB initialization. So once all the virtual machines are configured and everything is done, we initialize the cluster. Cluster initialization step is taken care by this FDB init function, which configures redundancy. It sets the multi-region, it sets the coordinators, and initializes the cluster. Basically, once everything is done, we'll be able to see that now the cluster is initialized. We publish the file to our storage accounts, and that file can be used to connect to FoundationDB cluster. So this is how we are configuring FoundationDB cluster, and the process is very streamlined and functional. So now we have provisioning done, configuration done. Now we'll be moving to showcase you that how we are doing the day-to-day operations and managing the FoundationDB cluster. So I'll be heading over to Deekshit. He'll be talking about which metrics we are monitoring, how we are logging, which FoundationDB utilities we are using. So yeah, over to you, Deekshit.
Thank you, Aakash, for your high-level explanation about FTP cluster provisioning and configuration management. My name is Deekshit. I'm working as a senior SRE engineer. 2 years back, I joined in Adobe and started my career with setting up of FoundationDB. Okay, so today my main agenda is about covering operational aspects of FoundationDB. For example, when we are running issues with FoundationDB cluster, like the database is responding very slow, or the transaction latency is increasing, or queries are timing out, then how do we start troubleshooting the issue? Immediately we check the metrics, like dashboards, we can check it, and even we check the log records, what is happening in the logging. Otherwise, we use some external utilities to debug the issues. Okay, so before going into deep dive, we have to understand what components we need to monitor in FDB. So at a high level, the FoundationDB cluster was divided into control plane and data plane. Even these two systems subdivided into total 4 subsystems. Like the control plane, we can call it as a configuration system. Then that data plane was divided into 3 subsystems: transaction system, log system, and storage system. Yeah, so here the configuration system will be helpful when we are connecting to the FoundationDB cluster. When we are performing FoundationDB reads and writes, the transaction system and log system plays a crucial role. So in FoundationDB, the actual data we are storing in the storage system. So even in the architecture diagram, we can clearly notice multiple FoundationDB roles in each subsystem, like control plane is having coordinators, cluster controller, data distributor. Even transaction system is having like proxies, log system, log servers, storage system is having storage servers. Because when we are checking the metrics or when we are troubleshooting the logs, we have to identify which FDB role is emitting the metrics or logs, and we have to troubleshoot it accordingly. So that's why these four subsystems are very important in FoundationDB, even for provisioning or monitoring. Okay, for example, right now, we want to collect the metrics from FoundationDB. So what components we have to install it? So we have to install node exporter. So this node exporter helps to collect the metrics at Linux VM level, like what is the uptime, what is CPU utilization, memory, context switches, even network packets. So if we want to collect the metrics of FoundationDB, we need to install FoundationDB exporter. This will give you the metrics related to the workload on the FoundationDB databases. So next, I will cover some of the important metrics in the FoundationDB. So the first one is like database availability metrics. So when we are running FoundationDB cluster, we always want to know whether the FoundationDB cluster is up or not. So that time this metrics will helpful to us. Even we can set the alerts in the Prometheus on this like database available. Then coming to fault tolerance, our FoundationDB systems are fault tolerant across zone levels and even at the data center levels. So currently in our system, we configured the fault tolerance margin as 2. So based on the fault tolerance loss margin, we can able to trigger the alerts and we can able to monitor it. Then coming to process and mission count. So in the FoundationDB, when we are running FoundationDB process, each process will bind it to the one CPU core. So because of that reason, we will run multiple FoundationDB process in single VM. So currently in our production cluster, we have total 46 mission count we have it. But across this 46 mission count, we are running total 297 processes. It's very difficult to monitor which one is up and which one is down. So that time actually this metrics really helpful to us in the dashboards like process count, what is the mission count. For example, when we are doing operations like upgrade we are doing or rolling upgrade we are doing, so to minimize the impact, we do the exclusion of the missions and exclusion of the process. That time we can use excluded process count and excluded mission count. Then this is also one of the important metrics. Yeah, that is recoveries. That is called cluster generation metrics. So in FoundationDB, when we are discussing about architecture diagram, we discussed on the roles. So whenever any role change happens, immediately, like in the transaction system, if any cluster controller or some role change was happened, immediately FoundationDB internally triggers a recovery. That time it will increase the generation metric, even if there is any configuration change or if there is any process change. So that time internally FoundationDB performs recovery. Immediately the generation metric will increase by 2 if it is a successful recovery. If it increases only by 1 means the recovery was stalled, immediately we have to look into the issue. Then coming to the workload metrics. So when we are running a database, we always want to know the load on the load on the database, like how many reads we are performing, like workload read operation, how many write operation we are performing, how many transactions we have started, or how many transactions we have committed, or even how many conflicted transactions we have. So we have to monitor all these metrics. Then coming to latency metrics, because when we are performing transactions in FoundationDB, the FoundationDB is a multi-version concurrency control system. So when you are performing a read operation or write operation, the first operation it will happen is getting the read version. That is called GRV. GRV probe latency. What is the latency on this? What is the read probe latency? Or what is the commit probe latency when you are performing write operation? Even similar metrics that is at the client level also, we have to monitor. Then coming to the cluster load. So we always have to know what is the back pressure, or are we creating any back pressure on the foundation DB? So the rate keeper is also one of the foundation DB role. The rate keeper limit will tell the number of transactions the cluster is allowing to start per second. The rate keeper released transactions, the number of transactions rate keeper released per second, and the storage queue. This is one of the very important metrics where exactly we are storing the data. So here, the largest write queue on the storage system. So that time where the data is being persisted on the memory, but not being committed to the disk. That will tell you about the storage queue. Even same for the log queue. This is also about the largest write queue on the transaction log. So which will be available on the transaction log, but is still not durable to the storage servers. Yeah, then I'm coming to the disk utilization. We are storing terabytes of data in Foundation DB storage subsystem. So by default, when we are storing data in Foundation DB, the data will be distributed equally among all the storage nodes. So here we can able to clearly see we have around total 30 nodes in the primary and secondary data center. We can see like almost all disks are utilizing around 37 to 38%. Even we can have a variation around 4 to 5% is also not an issue. But yeah, now in our Foundation DB clusters, we faced an issue with this data distribution, because what happens is over the time, over the time, due to the disk fragmentation issues or any hotkey problems, the data will be unevenly distributed on Foundation DB cluster. So even when it is unevenly distributed, even if you scale up the Foundation DB nodes, it doesn't help, but it will bring down the somewhat disk utilization, but still the data will be unevenly distributed. So we faced this issue in multiple production clusters. Like after 2 years, we faced this issue. Then immediately we explored, and for fixing this issue, we have to apply a configuration called perpetual storage. So perpetual storage is like a feature that forces the data distributor. So in Foundation DB, the data distributor plays a key role for rebalancing the data. So that time this configuration helps to build the new storage in the storage system. So what is the algorithm of the perpetual storage? So what it will do is immediately it will order storage servers by their created time, like from oldest to newest. Then for each storage server, it will one at a time, it will exclude the storage server. For example, if you are running around 7 processes in one storage server, at that time it will exclude only one process. It always minimize the impact on the live traffic. That's why it excludes at a time only one storage process. And it will wait until all data has been moved off the storage server. Then again, it includes a storage back. Then it performs same operations on the next storage server. So after applying this configuration on our all production clusters, so here you can see 30%, 67% uneven distribution. So after applying it, so we got actually the disk utilization came back to 29%, around 30, 36, like 5 to 6% of variation. So it helped in two ways. One is we got actually lot of free disk space, we got it, and even it solved the problem of data skewness. Yeah, then I'm coming to the FDB logging. So by default, Foundation DB writes all the logs in XML format. But if you want the files are in JSON format, you have to update this configuration in the Foundation DB config file, like trace format, we have to put it as JSON. So even in the logs also, we can able to get the complete subsystem information at the role level. For example, when you are checking this log format, so here we can see the role says SS. SS means it's a storage server. So this log record was related to the storage subsystem. Even if, for example, if you are getting role as CD, it's a coordinator. Then we have to understand, okay, it is related with the configuration system. If it is TL, it's a transaction log. So this log record was related to the transaction subsystem, because understanding these subsystems really help how to troubleshoot the issue further. Okay, then I want to give you the demo about FDB Explorer. This is one of the open source utility. In FoundationDB clusters, when we are, so yeah, in FoundationDB clusters, we have a cluster status JSON file. So this status JSON file is having the information of all the subsystems. So, but if you want to go through the complete JSON file, the view was, it's very difficult to understand all the properties, but this Explorer utility works like a terminal UI. Yeah, so here actually, so this Explorer utility reads the JSON file, and first it will show what is the cluster health. Like the cluster health is healthy, how many replicas we have, 3 replicas, what is the recovery state, and what is the cluster workload, how many transactions started. You can able to notice all these things. And one more thing, the first tab is locality, because when we are bringing up large production cluster, around 46 node cluster, it's very difficult to identify which data center, which IP address is sitting, and which port number it is binding, and what foundation DB role it is playing. So it's very difficult to identify, but by using this utility, we can understand this IP, the port number 4506 is playing a role of storage role, like 4500, that is acting as a coordinator. So then coming to the usage overview. So when you have so many nodes, you want to track what is the CPU activity, what is the RAM usage, disk usage. So we can able to monitor everything at a single place. Then coming to the storage process. So in storage process also, even what is the disk activity at the process level, this is even at the what is the KV storage, because foundation DB is a key value store. So at this process level, like 4500 level, it stored 58 GB of data, and how many queries we are performing on it, we can able to see complete information. Then coming to the log process, even this is related with the transaction subsystem. So here we can see what is the queue we have it, what is the queue length, what is the disk activity, even disk usage, we can able to notice. Even if you are running any backups, you can able to monitor those metrics. Even DR backups also, we can able to get that information. Yeah, this is about FDB Explorer demo. And then what are the key takeaways? Yeah, so recommendation is to like use multi-DC setup for high availability and fault tolerant system, and use suitable infrastructure as a code tools and a config management process for provisioning FDB clusters, and create automations for in-place configuration changes on cluster. And we always have to track key FDB metrics like disk usage, transaction latency, skewness. Even one of the configuration perpetual storage, because this is very handy to reduce the skewness. Yeah, that's it. Now open to question and answers.
Thank you, Aakash and Deekshit. Just wanted to get a quick shout out. I think Jing Yu, who works at Apple, he was the one that actually recommended Perpetual Wiggle to us in our last meetup in September. And then the SRE team jumped on, tested it out, and we were able to roll it across, all our prod clusters like within a month-ish. So definitely a big achievement there. Is there any other questions from folks on the call?
So Dikshit, Akash, I do have one question. So how do we how are we managing the configuration inside it? I mean, are we using any external tool like Chef or Ansible, or for DBs? I mean, itself is storing the configuration.
So, Ranjan, so we have different setup in different FoundationDB clusters. So somewhere we are using a utility that we have written in Go, which manages these. And we are also using some config management tools also and new setups that we are doing.
Okay, thank you.
Any other questions?
Yeah.
I think there's a question on the chat pod. Has anyone have experience in sending open telemetry data from FDB cluster to an OTEL endpoint? I don't think we've tried that.
Yeah, right now we are forwarding the logs directly to the Splunk. We have not yet tried the open telemetry
Yeah.
connector.
Yeah.
Yeah, if you don't have any queries, I'm stop sharing the screen.
Okay. We are close to time. Just want to again give a shout out to our guest speakers, Johannes, Aakash, and Deekshit. Definitely very insightful. If people are interested, you can join the meetup group. Most likely we'll have our next session next year, just because a lot of folks are on PTO in December. But if you have any questions, you can definitely post in that forum, or you can definitely reach out to us for any of the Adobe internal folks. Okay, thank you, everyone.
Thank you, everyone.
Yeah, thanks
Thank you,
everyone.
everyone.